Right, I'm back. Can everybody hear me again? The repeater strikes back. Okay, let's crack on. So we will skip introductions and the 1AV stuff because you all know that. Okay, so what I want to go over in this session is how we conduct a survey for Cel-Fi. So what information we're looking to find out when we go and investigate if it's possible to install. We're going to go over the different types of aerial available to you, and also best practices for minimizing loss on installation. So, okay, we've covered this. So the first question is, why do we conduct a survey? Why do we not just go and sort of just install it? And the reason is as I said in the previous session, proper positioning can reduce oscillation. So by properly planning the project, we can essentially allow the system to operate better, because if it's well planned, it can run at a higher power. It won't have to dial back its power so that it doesn't oscillate. Also, the other reason is sometimes things can catch you out. You will find an area that you would have thought had good reception doesn't. For some reason, it could be there's some pipes running adjacent to somewhere, or the direction the antenna is pointing, the direction the local base station is in is just, there's something in the way. There's a massive great tree somewhere and you wouldn't have expected it. So you need to go and establish in advance what needs covering, where we're going to put our antenna, what areas in the house need antennas internally. The other reason is sometimes if you get lucky, you might find that actually there's a location inside that has fantastic reception. If you find that, it actually means you can use an indoor antenna, so you won't even need to go up on the roof and put an antenna on a pole or on a wall. It might just be that actually, due to some sort of fluky situation, they've got areas of the house where the reception is absolutely bang on, in which case you can just stick an antenna, on the ceiling or on the side of the wall indoors, and that will mean you can do a very quick, very sort of low hassle install to get that working. The other key thing is talk to your clients about their expectations. Do they want, is it just a case of they've got a few rooms where they get very frustrated, they lose signal, or do they want to be able to have the whole house bathed in signal, as I call it? So as an example, generally with sort of small houses, it might be they say to you, actually, we need to get, we've got an office in the basement or a cinema in the basement, we need signal down there, we're not too fussed about the other areas. In which case it's very simple. Whereas we have a couple of ongoing projects that are huge MDUs that need, the whole building needs coverage, in which case that's absolutely doable. It's just going to be more expensive and we will need more hardware to cover that. That is why we go and do surveys, to establish what the requirements are, where is reception needed. So what do you need to conduct a Cel-Fi survey? You're going to need an Android phone. Unfortunately, the app that we're all using to measure cellular information is not available on iOS. The reason is that Apple locked down the information the app needs to give you its readings. The phone is more than capable of doing it. It's just a case of Apple being a bit difficult and locking down that information. So you're going to need an Android phone. And just pick up a cheap, if you think you're going to start doing a lot of this sort of thing, go and grab a cheap secondhand Android phone. And the next thing you'll want to go and get 4 pay-as-you-go SIMs for each network. So I actually have a dual SIM phone, which is nice. So I can put 2 SIMs in, walk around and do the survey for those networks. And then I flip over to the 2 other networks and go around and do it again. But you don't need that. You just need, ideally, whatever mobile network the customer wants, you're going to want to have a SIM of that network. The other thing is roof access. If possible, as I say, I've sort of put this roof access ideally, so you can go and check the signal on the roof and where you're going to put the antenna. But as I said in the slide, it's very reasonable for you to assume that if you go and walk around outdoors and you find that actually your signal outdoors is pretty good, you can very reasonably assume that as you go higher up, that is only going to improve. It would have to be a very strange set of circumstances for an antenna that is placed higher up outdoors to have worse signal than on the ground. It could happen. I'm trying to think of how it can happen. At the moment, I can't think how that could happen. So I'm sure someone will come and tell me, oh, it happened here for this reason. But at the moment, I can't think of a reason why that would happen. So Network Cel-Info Lite is a great app that will tell you a lot of information about a mobile signal. What is important is actually your bars on your phone are a very poor indicator of how good the signal actually is. The reason is they're completely determined by the maker of the mobile phone. It's just to do with what they consider 4 bars might be different from what another maker considers 4 bars. Network Cel-Info Lite will actually give you a good reading. So this is a reading I actually took earlier today when I was putting these slides together of my O2 coverage in our office. Yes, Gabby, you can. There is a limit based on how much power you've got, but you can use a splitter to have multiple antennas if you want. So what we can see here is, so my O2 coverage in sort of the warehouse was minus 105 dBs. That would not be good enough for running around a building. You can sort of see vaguely at the corner that you can also see my EE coverage from my dual SIM. That's a bit better, but not great. But this is, you can go off this. So rely on this reading. What you're looking for is a location that has a signal in the green. If you can get a signal in the green somewhere on the property, that should be where you put your antenna. Now, there's a term I'm going to use a lot now that I'm going to call donor signal. So donor signal is the signal that we are going to propagate around the building. I think, in fact, I have a slide next just to explain that. Yeah, donor signal. So donor signal is what we call sort of that initial signal that we're going to grab. And that's why we call them repeaters, because you have a donor and then that donor signal is repeated. The phrase we normally use is a donor antenna is the antenna that will normally be outdoors that is picking up the signal. And then you've got a server antenna, which is the antenna that is indoors and is serving that signal to whatever location you're in. And you are looking to do whatever you can to make that donor signal as good as possible. And there's 2 aspects to that. The first aspect is obviously choosing the right antenna, which we'll go over, and making sure that's done correctly. And the second thing you're going to want to do is install the right cable so that that signal from that antenna gets to your booster with as little loss as possible. So the key thing about Cel-Fi, and I can't stress this enough, is you will have much better performance if you do everything you can to make sure that the signal your repeater is receiving is as good as possible. Once it's got that, getting it around the house is easy. The job's basically done once you've got that, putting a few antennas around the house and running some RF or some CAT, depending on what product you use. That's easy. We can do that all day. Getting that initial signal is your real sort of challenge. So yeah, what you got to remember about this is when we're repeating a signal, so we're repeating our donor signal, all the booster is doing is adding power. There is no way of reducing noise. So if you get a very powerful but noisy signal, which is what sometimes happens on our phone. Sometimes we have 4 bars, but the reception's crap. That is happening because you've got this phone is detecting a powerful signal, but actually it's a very noisy signal. What Cel-Info Lite gives you is the power, but also how noisy it is, so you can get a very good idea of how good that signal is. Essentially, if the signal, if you've got a green, where it says O2 UK on that picture, if that was in green, we're good to go. We're happy with repeating that. And I've met loads of guys who've been installing sort of mobile repeaters for ages, and they all use this app. There's no need to use anything sort of more fancy than this at the moment. The other really useful feature about the app is it is able to triangulate the nearest base station. So what it can do is if you click on the map button, it will basically show you where the nearest base station is. So what you do is you can then point your antenna in this location. And in an ideal situation, what you're going to want to do is have the donor antenna also wants to be on the side of the house that is facing that way. The reason is to avoid oscillation. You don't want the antenna sort of pointing across the house, so it picks up the internal antennas. You want the donor antenna pointing away from the house. So if you get the option, you should always be looking for which side of the house is facing the base station, and you want your antenna on that side so the antenna doesn't have to point inwards. If it does, it's not the end of the world. It will just mean the system won't be able to be as powerful as it could have been if it was on the other side. So you've got a few options for antennas. They basically go from sort of good, better, best, essentially. And there's a couple of situations where you might. So the cheapest antenna, and this is kind of the standard, standard sort of run-of-the-mill thing, is what we call a wideband panel antenna. So this antenna has quite a wide capture area, so it can be used, for instance, to pick up multiple networks. And what you can do is, let's say you're doing an install where they want a EE and O2 coverage. If the signal for both those networks is good, all you do is you put a single antenna in, and then you split the signal from that antenna, one to a booster configure for O2, one to a booster configure for EE, and then you'll be fine. You would use this in situations where your outdoor signal is fantastic and there's no need to spend any more money on an antenna because you've got loads of signal outdoors. Next up is where if signal gets a bit worse. So this is a directional antenna, so typically you'd be installing this on a pole, and you're looking to point it in the direction of your nearest base station. So this is a directional antenna. It's got a smaller cone catchment area. It's really likely only for picking up one network because you're going to be pointing at the base station. So if we're doing multiple networks, you're likely going to need multiples of this type of antenna, but you'll get a stronger signal by using this than, say, your phone. If your phone is showing you an orange level signal, odds are that if you use a directional antenna like this, actually what you get are good enough. And then if things are really bad, we switch to an LPDA antenna, and I'll give bonus points to anyone that can tell me what LPDA stands for. I had to Google it today because I thought I knew what it was, and I was very, very wrong. It's something dipole something. I think it's low pass dipole antenna or something. So these are quite expensive. You're probably looking at about 200 quid for one of these. These are for use when the signal is very bad, so when you've got very little to work with, but we need a solution. You use one of these. The other situation where you would use one of these is if you're going to have quite a long cable run to your booster. So as an example, if it's a massive mansion and this is going high up and your booster's got to go in a rack room, 30, 40, 50 meters away, you would use an antenna like this because you have a stronger signal. So your loss from your antenna down to your booster is less because you've got a stronger signal to start with because you've got a more heavy duty antenna, and you really need to point these towards the base station. These are very directional. They're not going to pick up anything on the sides. It's going to be, you're going to want to find where that base station is and you're going to want to point it straight at it. And so these are about 200 quid. So not cheap, but you might need to use them if the signal's poor. So then we're on to cabling. So this is the next most critical part. It's all very well having a good signal, but what we then need to do is to make sure that that signal is not all lost as it goes onto cable. For those of you who've been doing any sort of RF installations for TV in the past, you'll know that one problem is that because we're essentially just using copper and we've got an analog signal, the longer the cable run is, the worse that signal gets. And that's why you have things, that rebalance and all that sort of stuff. We don't have that with Cel-Fi. What we have to do is use very good quality RF cable. So it's very unlikely, for instance, that you would be able to install Cel-Fi on a pre-existing coax system. So let's say a house has an old coax system that used to be used for TV and has been upgraded. Odds are you're probably not going to be able to repurpose that for mobile phones because it probably won't be good enough quality to not lose too much of the signal. So there's a couple of things you're looking for. Obviously, 1AV, we sell this type of coax, and I'm going to use them as an example when I talk about the next bit, but you don't have to use that. What you are looking for is 50 ohm coax, and you also need to look at the frequencies it supports, because you want to minimize the loss to no less than minus 10 dBs of loss. Let me show you how you do that. So I'm going to switch to my screen, and we're probably going to go sort of, it's going to go all funny for a sec. So yeah, I think you should be able to see my screen now. Can everyone see my screen? Are you seeing this WebRow form? Oh, hold on. What do I do? There we go. Now it'll work. There we go. Okay, so these are the technical specifications for the WebRow cable. Is that working? Can everyone see that? Yeah, you can. Can everyone see the WebRow thing when I put it up then? Great. So we at 1AV, we sell two types of cable from WebRow, 50 ohm coax. The figure we're looking for is, so this is the Web 400. So we know that mobile frequency caps out at 2100. So here we've got a figure that attenuation wise at 100 meters at 2000 megahertz, that's close enough for 2100 for us to know we've got 21.5 dBs of loss. So essentially that is too much loss for 100 meters. But actually, if we're at 30 meters, we're looking at 7 dBs of loss. And that's fine. So generally, we tend to say that we will recommend to you the Web 400 cable up to lengths of about 30 meters. And then what happens is once we go beyond that, we switch to the Web 600, which works out, oh, this cable, just for information, this cable works out at something like £2 a meter. And this cable works out at about £3 a meter. So we can see that this cable has 14 dBs of loss at 100 meters. So again, we couldn't do 100 meters really with this. If you needed to go 100 meters, there is cable available to do it, but it gets quite expensive. It's something like £1,000. I think it's about 1,100 quid for 100 meters or something. So it's possible, but gets expensive. But you can see that the Web 600 at 100 meters, it's got 14 dBs of loss. So you could probably do 50 to 60 meters on this cable and maintain a good enough signal down to the booster that you would get good performance. Now let's quickly switch back to the slides. Oh, where have my slides gone? Hold on. Back to my slides. Oh, we're back at the start again. Let's quickly flick through these. So back on the slide now. So that is, let me just turn my screen share off so I don't get that on. So that is the first thing. Now, you don't have to use our cable. As I say, you can use whatever cable you want. Lots of companies do appropriate cables, but that's the information you're looking for. You're looking at 2100 megahertz. Now, as I said earlier, 2100 megahertz is only one of the bands. So actually, a lot of 3G is actually on the 800 megahertz band, and obviously the loss on that will be less. So it might just be that actually, you know, if we've got a long distance, we might not be able to get that band 20 signal down, but we might get the, you know, the 800 megahertz going. There's lots of possibilities. So just because it's a long run doesn't mean it's not possible. We've just got to adjust, you know, what we're looking to do with the system based on that. So the other thing to be aware of with this type of install is the terminations for that type of cable are almost always what we call N-type plugs. And typically you will install these yourself. Now we can do this for you. So if, for instance, you want us to pre-terminate the cable for you with the adapters, we'll do that for you. If you just say, yep, I want 2 lengths of 50 meters with N-type plugs and you want us to terminate those for you, we can do that. Alternatively, if you want to learn how to do it, being completely honest with you, we learn how to do it on YouTube. So we had never dealt with N-type plugs up until about a few months ago. So we just went and watched a video on YouTube on how to terminate N-type adapters, and we learned how to do it, and we had learned how to do it in sort of 10 minutes. It's not hard. So these are just the type of plugs. But what you've got to watch is where you can get caught out is there's two sort of categories of products with Cel-Fi. There's the GoX and the Solo, which are RF only, and those use SMA adapters. And then there's the Quattro system, which is the system that distributes over CAT, and that uses something called a QMA adapter. So the only thing you've got to watch is you always need to remember to order the right type of adapters to go from N either to SMA or from N to QMA. We get, a lot of people get caught out by that. We try when people are placing orders, we try and catch it for them and make sure that they've got the right adapters. But if you were to order something online, you might forget. You might forget to order those. We have those available. Just make sure you've got them. So other thing to be aware of with that cabling, it's got a very low bend radius. You need to plan for this. Ideally, you really just want this stuff going down a riser into the main rack room, and then you don't want to be having to sort of run this stuff all around the house because it is hard to work with. It doesn't bend very far at all. The best thing you can do, and this is key, is the best practice is to try and minimize the distance between your donut antenna and your booster. What that means is actually you may not want to put your boosters in the main rack room. It might actually make more sense to put the boosters themselves up in, say, the attic, right next to the antenna. And that way you have a very, very short cable run from the antenna to the booster. So the booster's getting fantastic signal. And then you run internal RF or CAT down through the house to your internal antennas. That is best practice because essentially the signal that is going on your internal cable, the signal that's going down that cable is very strong because it's coming from an amplifier. By minimizing that distance between your roof antenna and your booster, you really are doing the best possible practice. That is considered best practice. It's just not always possible. Sometimes, the boosting software, you go in and all the CAT cabling is going from the rack room or whatever, and it has to be down there. But if you get the chance to design the system from scratch, put your boosters higher up near the antennas if you can. It's less headaches and better performance. So as I said, I've said this already, but your internal runs are not a big of an issue. So loss isn't such a problem internally because essentially the booster has so much gain and power that if there is a lot of loss to the antenna, it'll actually just increase its power to make up for it. So internal loss is nowhere near as big of a problem as loss from your donor antenna to your main booster. And in the case of Quattro, the internal run is all so you're looking to minimize loss to 10 dBs, to minus 10 dBs. If you had a bit more loss than that, it's not the end of the world. It just means the system can't perform as well. What we're trying to do here is just get the system as powerful as possible. So yeah, you're looking to install cable that at the length at 2100 megahertz has a maximum of 10 dBs of loss. And in the case of Quattro, all your internal run are done over CAT cable, so you get no loss at all internally. Let me just go back quickly. So what you'll see is most of the signal goes to green when you get to about minus 90 dB. So minus 90 dB is a good place to be. So if you use this app and you find that it's above minus 90 dB signal, that is a good place to be. The system will be happy with that. It has to be sort of minus 100 to minus 90. It's workable. It just means that the performance indoors won't be as good. So minus 90 dB going in, and then no more than 10 dBs of loss going down the cable. Where did we get to? So quick note about Quattro. So Quattro can be used residentially, and we do install it a lot residentially, but it's actually designed for commercial use. So that means it supports something called MIMO, which is multi-in, multi-out, which is a feature on mobiles. MIMO is a way of antennas serving a lot of phones at once. Less important for indoors, but what that does mean is if you are doing an install with MIMO and with Quattro, the Cel-Fi Quattro system, your antenna and your main unit booster will require 2 RF runs. So from the antenna down to the main booster, if you're doing Quattro, you need 2 RF runs rather than 1. If you're just using the GoX, and GoX is by far the most standard thing you install. And I say the next session I'm doing on Cel-Fi is in January, so I'm about to go on holiday. Over the next 2 weeks, it's HD Anywhere. But in January, I'll be doing the next lot of these, and I'm going to go more in depth on the differences on the different types of boosters. But the GoX is sort of the standard, and that is all RF internally, and then Quattro uses CAT to reduce loss. But yeah, it's worth remembering that if you do start speccing a Quattro system, you'll require 2 RF runs for the antenna, which obviously means if you're doing all 4 networks, that means you've got 8 runs of RF from the roof, and that is where it becomes really, really handy to install your main boosters upstairs in the attic rather than down in the wrap room, because it saves you having to run 8 very low bend radius cable runs all the way down. Any questions? Yep, I'll forward the slides to you. Thank you both for coming. I really appreciate it. It gives me a chance to sort of get used to doing these. So it's the second set of webinars we've done. I always enjoy it, and it's nice to speak to you both. Yep, so if you've got any questions, just fire them over emails, and we'll get those answered for you. And if you need pricing and things like that, just contact whoever your account manager is, and we'll get those over to you as well. So let us know. Thank you very much for coming. I hope you enjoyed it.